Ok, en caso de que llegue alguien no hablante español, yo me imagino que cambiase el inglés en algún momento. Así que
Sí. Además que esto está quedando grabado, ¿no? ¿O después se queda grabado esto?
sí,
¿Se sube a algún lado? Ya.
sí. Si quieren, empezáis tú, Tono. Démosle un minuto más y llega alguien más y empezamos, ¿no? Son
Vale,
justo
vale.
las 3:50, esperamos un
Sí,
minuto.
don't worry, don't worry. Yo por mientras voy a proyectar acá y me voy a cambiar lentamente a un modo inglés, por si esto después lo ve alguien que no habla español. Okay, I think I should start now.
Yeah, go ahead.
Okay, so thank you very much to the organizers for including my work, my paper in the program. I'm very happy to present my working paper, Costly Multi-Unit Search. This is joint work with Rodrigo Harrison, also from the Adolfo Ibáñez University here in Chile. So feel free to interrupt me whenever you have questions. I'm really looking forward for your comments, your opinions, suggestions. So whenever you have a question, feel free to just stop me. Okay. I'm aware that I have just 25 minutes, so I'm just going to say one thing before I start. I'm going to spend 2 slides motivating the paper very briefly, and then I will jump to the model in the slide number 3. Okay, and the rest is just about my results, and I'm going to be using a lot of figures so that I can show you my takeout message graphically rather than analytically. Okay, so what I want you to do throughout this presentation is that you think you're trying to sell a good or sell an asset. Okay, of course there are many reasons why you might want to do that. Maybe your preference change or the environment has adjusted in such a way that you just want to sell something. Okay, and so think about you're trying to sell a large parcel to cover medical expenses, or think about the case of a real estate broker holding a large number of properties that he's trying to sell off, or even think about store liquidations, a car dealership, or even a consultant that is trying to sell his time partially. Okay, all these cases are optimal inventory liquidation problems. I'm sure the one you also thought about is also an inventory liquidation problem. So and it has, in our opinion, it has 4 key ingredients that we try to model to include in our model, and those are: first, there are search frictions. So we're going to be building a sequential search model a la McCall. Number 2, you might be holding more than just one unit. So this is going to be a multi-unit liquidation. Number 3, there's no organized competitive market for what you're trying to sell. And so trade is going to be fully decentralized. So you're going to be the seller is going to be facing frictions. And in addition, he's going to be facing selling restriction. This is something we call purchase caps throughout the paper. Okay, so it's not that you want to sell something. Well, you just go to the market, you observe a price, and you sell what the amount you want. It's not like that. You have to meet people, and those guys that might want to buy from you might not be willing to buy all the amount you're holding. Okay, and number 4, you're going to be the seller is going to be facing a fixed per period search cost. Okay, so while you're holding your inventory, the good you're trying to sell, you're going to be facing fixed holding cost. So think about warehousing, salaries, or insurance cost. All right, and these are the 4 key ingredients that we include in our model. What is the goal here? Well, we ask ourselves, what is the optimal liquidation strategy? Then, and by that we mean, how does the behavior changes during the liquidation process? Should I should I quit searching at some point? After all, I'm facing a fixed per period search cost. So maybe at some point I just want to quit, right? And if I quit, should I always quit? Should I quit whenever I'm holding a low amount of inventory? When should I quit search? If I'm searching, if I'm quitting, if I'm not, say I'm searching, what prices should I pick? What reservation prices should I pick in order to sell the units I'm holding? Okay, so this is an optimal, if you want, an optimal liquidation, optimal trading strategy that we want to characterize. And as such, we think that it might have some applications in optimal trading strategies in finance, over-the-counter markets, or in models that combines money and search, real assets. So those are the applications we have in mind, okay? Despite the fact that our showcase application, and this is the one I'm going to be using in the next, starting from the next slide, is going to be an optimal inventory liquidation problem, okay? So that's our goal. Now let's jump to the model. We're going to be consider a time, that time is discrete and goes forever. As usual, there's a discount factor beta. And so all the blue is the important parts, okay? So the seller is going to be holding inventory of indivisible units, say 10 cars, 20 cars. And each period, he's going to be facing a search cost, F, that if he wants to search, he's going to have to pay that cost every time he wants to search, okay? Of course, this can be avoided if everything is liquidated. If I don't have any units left, well, I don't have to pay anything else. Or if I quit, right? If I just quit and I abandon my inventory, of course, I don't have to search, so I don't have to pay the fixed cost. All right. We're going to be assuming, and this is without loss of generality, that if I quit, I'm going to be selling all my inventory at a zero price. All right. It could be a savage price, but let's assume that that is zero. If I decide to search, right? If the seller decides to search, he's going to be facing a flow arrival of buyers. And every time I meet a buyer, the seller meets a buyer, those buyers are going to be offering a limit order. So a limit order is this per PL, okay? And that reads that the buyer would like to buy at most L units at the price P per unit, right? And of course, I might be meeting buyers with different probabilities. So alpha L is going to account for those different probabilities of meeting different buyers with different demand size, okay? And so conditional on the buyer limit order PL, the seller is going to have to choose how many units he sells, right? So he could sell 0, of course, 1, or the maximum he could sell is the minimum between the units the seller is holding and the units the other guy wants to take from him, right? And so the seller tries to maximize the present value of cash inflows, and we're gonna be calling that VN. This is the value function where the only state variable is the number of units he's holding. All right. And so the next step is to set up a Bellman equation and solve the Bellman equation. So this is the Bellman equation. If you take a look at this Bellman equation, you're going to see two max operators. These are the decisions the seller has to resolve, right? So first, if I'm searching, right, I'm going to be paying this fixed cost F, and there's a discount, and then an expectation on the offer, right? So I might I might meet someone who wants to take at most L units from me, in which case I could sell anything between 0 and the minimum between L and N. And if I sell, I sell at the offered price, P, right? And if I sell I units, well, my continuation value is V N minus I, right? And if I don't search, I get 0, right? So this is the maximum between searching and not searching, and conditional that on searching, I have to choose the optimal the optimal units I will sell. So we need to specify here a search rule, right? And the search rule is basically two decisions: when to stop searching, and number two, how many units to sell. And that is equivalent to answer the question, how to price each unit. If I'm holding 10 units, well, I will need to define a reservation price to sell each of the units I'm holding. Okay, so the next slide, I'm going to be talking briefly about the optimal search strategy, and then all the rest is going to be about optimal selling strategy. Okay, about the optimal search strategy, well, what we say in the paper is that there is a shutdown decision, right? I'm only going to be, so the seller, I usually refer to the seller as myself, right? So, so the seller is going to start searching whenever the cost is low enough, right? And he's going to quit eventually. He's going to abandon inventory whenever his inventory is low enough. This is what lemma 1 is saying. If the cost is low enough, okay, I will start searching, but I will stop at some point. And that point is whenever my inventory is above a threshold value, and not, right? And not solve this inequality in one. But given that I have just a short amount of time, I'm just going to explain to you the intuition. This is basically saying that, so a few conclusions that can be derived from lemma 1 is that a strategy that combines searching but eventually shutting down only arises with multiple unit sales, right? So if every time I meet someone, that someone is willing to buy only 1 unit from me, if I ever start searching, I only stop when I have fully sold my inventory, right? Single unit sales implies that I fully sell my inventory or I don't, right? But a strategy that combines, well, let's start searching and at some point let's stop and abandon inventory, only arises with multiple unit sales. And the second important message here is that notice that to characterize the optimal search strategy, we don't need to characterize the optimal selling strategy, right? Let me say that again. In order to characterize the optimal search strategy, we don't need to know what the optimal selling strategy is, right? But that doesn't work the other way around, right? So of course, the search strategy, the fact that I quit at some point, will impact the prices I choose for each of my units. And that's what we're going to be talking about next, right? So this is a figure. I'm going to skip this. So about the selling strategy, of course, as any sequential search problem, we're going to have to choose reservation prices. But this is not as in McCall's single unit search problem where I have to pick a reservation price in order to sell or not sell. Here, I will have to pick a different reservation price for each of the units I'm holding, right? And this is going to be governed by the shape of the value function. If I'm able to characterize the shape of the value function, whether it's increasing, decreasing, concave, convex, well, then I will be able to derive what the optimal reservation prices are. And given that the seller might quit search, right, I will have to take that into account also. If I'm holding, let's say, 5 units, my selling strategy is going to be different if I know that when I'm holding 2, I will quit, right? And so we have to characterize the cost of selling, and those costs of selling are endogenous objects, right? In particular, we're going to have to characterize the marginal cost of selling a unit, and that's just going to be the value lost. So let's say you're holding n units. If you want to know what the marginal cost of selling 1 unit is, well, just compute the value difference between Vn and Vn minus 1, right? How much your value falls, that's the marginal cost. right? And we also we're gonna have to characterize the average cost of selling, which is this phi nj, right? Which is just the average, right? Vn minus j divided by j, right? So we have to characterize this by induction, and that's what we do in the paper. We use an inductive logic, right? And let me just give you an intuition, and then I'm going to be showing you a few figures. What is the intuition? What is the driving force here for our results? Well, the fact that the seller, whenever he's selling, he's going to be balancing each unit optionality. So how the seller balances each unit optionality is critical. But when we combine a fixed cost and demand restriction purchase caps, each unit of inventories provides two kinds of optionalities. First, of course, if I'm holding, let's say, one extra unit, well, it improves the ability of the seller to sell more units, right? Of course. If I'm selling 10, if I'm holding 10 cars and then all of a sudden I have 11 cars, well, I'm just going to be able to sell one extra car every time I meet someone, right? So that's going to provide the seller a better selling optionality, right? But in addition, if I'm holding more units, I'm going to be able to split the fixed cost between more units, right? And that's going to provide the seller a better search optionality, what we call in the paper a better search optionality. The average selling cost is going to be lower. So in other words, more units allow me to sell more, right? And also to search more cheaply, right? And now, what we find in the paper is that the first optionality, what we call the selling optionality, is going to be decreasing in the size of the inventory exclusively due to the caps. The fact that there are demand restriction means that, of course, you're going to be able to sell more units, but, well, you might be restricted. So every time you're holding a larger inventory, that optionality is going to be lower, positive, but lower, right? Whereas the second optionality rises in N in the size of the inventory, simply because the fixed cost is going to be split among more units. So the fact that these two optionalities, so if I'm holding more units, the seller is going to be hold an optionality that's going to be decreasing due to the caps. But on the other hand, he's going to hold a better search optionality that's going to be increasing in the size of the inventory. The fact that this optionality vary differently as the size of the inventory changes implies that the marginal cost of selling is not going to be monotone, right? And the fact that we face a non-monotone marginal selling cost implies that the selling strategy is going to be discontinuous. So I'm not going to be selling each unit at a higher price, but instead bundling and discounts are going to arise as optimal strategies. Okay, and that's the takeout message of the paper. Okay, so given that I have just like 7 minutes, let me just jump to this figure, to this one. Sorry, to this one. So in this figure, I combined several cases. So take a look at this black linear function here. This is the case where this is the value function on the y-axis and the size of the inventory in the x-axis, right? And this is the case where there are no costs, no fixed costs, and no caps. So in that case, the value function rises linearly in the size of the inventory, and that means, take a look at the right panel. If I compute the value difference, since this is a linear function, this is a constant, right? And the value difference, remember, is the marginal cost. So in this case, in this black case, the marginal cost is a constant, right? So constant marginal cost means that if the price exceeds the marginal cost, I'm going to be selling all my units. If the price is below, I just don't sell, right? The The white circle case is the case where there are no caps, so no demand restrictions, but only a fixed cost. In that case, the value function kind of convexifies, right? It increases at an increasing rate. And that means that if I compute the value difference on the right panel, right, you're going to be seeing a function that increases, but the marginal cost is the mirror image of the right panel. So the marginal cost in this case is decreasing, right? So again, whenever in the case of just a fixed cost and no demand restriction, the marginal cost is going to be decreasing. The case with the gray squares is the case where there's no cost, but only purchase caps. And in that case, the value function is concave. And so you can see that the marginal cost is increasing, right? Remember to take a look at the mirror image of the right panel. So what happened when I combine the fixed cost, sort of the white circle case, and the caps, sort of the gray square case? Well, the marginal cost might not be monotone, right? And let me just give you an example of what happens. So this is the case where there's a fixed cost, and suppose buyers always arrive demanding 5 units, up to 5 units, right? So this is how the value difference look like. So you see that it's not monotone. It increases up to 5, then it falls, that increases again, and then it falls again, increases again, and so on and so forth, right? So highly non-monotone value differences. And this is, remember, this is the same panel of this is the same as the right panel here. So if you take a look at the mirror image of this, we're going to be, that would be the marginal cost. So say you're holding 7 units. If you're holding 7 units, the marginal cost of selling 1 unit is just this kind of 5, right? 5. The marginal cost of selling the second unit falls and is 3. And the marginal cost of selling the third unit is higher, is 7, and then it falls. So if I were to plot the marginal cost on the right panel, it would be like the black circle function, right? It falls and then increases and then falls again. So highly non-monotone marginal cost function. And the average cost is going to also look highly non-monotone. It falls first and then increases again, which means that what is my optimal selling strategy if I were to face this kind of case? Well, I'm going to be bundling units, right? I'm going to be selling either 2 units or 5 units, right? So bundling arises as an optimal selling strategy. If I were to hold A units, well, then the bundling is going to look very similar. I will either sell 3 units or 5 units. And the other cases are the same. If I were to hold 10 units, the same thing, given that the marginal cost in this case is decreasing, right? So bundling arises as an optimal selling strategy when the seller faces homogeneous demand. So buyers always arrive wanting to buy 5 units or 6 units from him. What happened in a more general case? So think about a case where he might be meeting buyers willing to buy 2 units from him, but also some others want to buy just 1 unit from him. Well, in this case, this left panel is how the value difference look like. Remember, the value difference, the mirror image of the value difference is the marginal cost, right? And so if you take a look at this, the marginal cost is increasing up to 6, right? So whenever I'm holding a large amount of units, this is saying that whenever I'm holding a large amount of units, I'm going to be selling an extra unit at a higher price. But at some point, this becomes highly non-monotone. And in that case, I'm going to be offering volume discounts, right? Because the marginal cost for 1 unit is going to be higher than for the second unit. Okay, So take
got one minute left.
Okay, thank you, Javier. And so this is what we found in the paper. We characterized this the value function by induction, and we're able to make sense of strategies that are commonly used during liquidations, and those are optimal bundling pricing and or strategies, more sophisticated strategies that combine selling at a premium whenever I'm holding a large amount of inventory, and sales, and by that I mean bundling and offering volume discounts when the inventory is low. Okay, the fact that we combine a fixed cost with multiple units is key, and we really believe that this pushes search theory into a richer class of problems that are not just optimal stopping exercises. Okay, and that's it. Thank you very much.
Great. I don't know if anyone has any questions or comments. We got 2 minutes. So I got one myself.
Good.
What about, to which extent the results depend on the assumption that the search cost is fixed and it's not a function of the amount of available units? Because in this way, when you were characterizing the value function, I guess there is a role for, perhaps I will search with more effort if I know that I just had one car left, relative to the case where I have like 25 cars left. You see what I mean?
Yeah, I understand. So that is a good question. And let me just divide my answer in two. First, I would say that if we were to assume a variable holding cost, right, not a fixed holding cost, the answer depends on what the shape of the assumed cost function is, right? If the cost function is concave, well, probably it's going to be hard to characterize what analytically, at least, what the shape of the value function is. If we assume a convex holding cost, well, maybe in that case it would be easier. What I have solved is that if we were to assume a linear holding cost, right, a linear holding cost, the value function is not necessarily monotone anymore. So it's going to look something like this. If you were to assume a linear holding cost, the value function would start looking something like this, right? And so you were to find an optimal inventory size, right? And so that is something that we're also exploring right now. What happens if you combine a fixed cost with this kind of variable holding cost, right? But that's the kind of things that would arise in this model. Instead of having a fully an increasing value function, the value function might stop being monotone, and at some point it would start decreasing, and so we would be able to say something else about the optimal inventory size, right? So that's the kind of things.
Okay, cool. All right. Thank you, Tono.
Well, thank you. Thank you for the question.
Let's move now to Miguel. Okay, you got 23. I got 25, but I will let you know at 23. I think you're muted, yeah.
Yeah, okay, thank you very much. Thank you all for coming. I'm going to talk about entry in generalized beauty contests, and this is a joint work with Silvia Martinez Gorricho from the Catholic University of Concepcion in Chile. And I want to start by asking or motivating the paper in a way by saying that, I mean, sometimes you think about situations like, I don't know, every time that a government, state, or region wants to promote innovation and R&D and so on, they want to create the next Silicon Valley or stuff like that. And the truth is that so far we haven't observed any Silicon Valley, any new Silicon Valley. And there are many projects, there are many attempts, but they seem to fail systematically. And this is the kind of questions that this model, though very abstract and applicable to many other situations, seems to be at least able to offer some kind of, or some approach to deal with this kind of questions, because this is like a general question that can be placed or presented in a similar fashion, like we say, why does a political association become a radicalized group? Or why do particular neighborhoods degenerate into slums? Or in general, why a particular group seems to fail somehow and to not be up to what it was supposed to be, in a sense. And that's the idea that we want, one of the issues that we might address with this kind of model. And the idea is that in all of these models, there is some kind of sense of community in which you need some kind of conformity, some kind of coordination of cooperation between the members of these groups that if it is not properly addressed, seems to lead to this default situation, this failure. And one of the applications as well, which is the one that I'm going to use like a leading example, is the possibility of creating, for example, a research institute or a research cluster in a university. And so the idea can be interpreted as follows. Let's say that you're a faculty member and you have to choose your next research project. And to simplify the situation, you just have one dimension in which you have to choose which type of projects to pursue. And that's going to be the theory empirics dimension. That can be extremes of this line with empirics on the left and theory on the right. And therefore, the paper that you write is going to have some percentage, some proportion of theory and empirics that is going to be close to one corner or the other. Now, interestingly, this generates a sort of trade-off between your own interest, which depend on your type, which could be your skills, the papers that you already wrote, the preferences that you have, etc., etc. But also, there is a sort of an external element that we are going to call the social norm, that reflects a sort of trend or mainstream or hot debate that is applicable at the moment. So when you have to decide which type of paper, you have your own preferences, your own type to that affects that decision, but also a sort of social component that you want to conform with, because this is going to be part of a community. For example, you want to do papers with co-authors, and therefore it's better if they are in the same line that you do, or simply because if you write a paper on the right hot topic at the moment, the publication possibilities go up. Now, this is something that the literature has considered so far, quite in many scenarios. So what we bring to, and in particular, this is going to be modeled as a beauty contest, a global, a generalized beauty contest. And in particular, the coordination part is reflected in the idea of trying to conform with the social norm. But the literature is missing, as far as we know, on the matter of voluntary participation. That is, implicitly, it is assumed that everyone is forced to participate in this game, in particular, that everyone in the university is forced to do research. However, we can easily think about outside options that you can do with your time, like, for example, teaching. And this possibility creates a wedge between the idea of economy, that will be the whole faculty, and the community, which would be just the group of people that decide to do research in this example. And this brings with it some interesting issues like the size and the composition of this community that are absent in the analysis of the literature, because by definition, the size and the composition is fixed. Everyone is part of this economy. And in particular, it brings also some interesting elements connected to the fact that it's not only the fact that you can choose whether to enter or not, but you're going to choose based on what you expect to observe and what you expect to earn by selecting the option of entering this research activity. For example, the type of papers that you expect to that the research institute is going to produce is going to be affecting your preferences via this mechanism that I mentioned before. But also the opposite is true, because if you expect a certain social norm to emerge, then you are going to be able to say whether it is worth for you to join or not this community. And hence, there is this interdependence between these two choices. In terms of research questions, what we want to do is find what is going to be the size, the composition, and the social norm that are going to emerge in equilibrium in this community. And in particular, as a comparative static exercise, how do these elements change when we change the attractiveness of this beauty contest? And this attractiveness is just the flip side of the outside option that we mentioned before. That is, notice that the more attractive is the teaching option, then the less attractive is the research option and vice versa. So in order to, methodologically, we are going to call the attractiveness of the beauty contest just the inverse or the negative of the outside option. And this is a new element that we bring to the table. So that's why we are interested in this particular comparative static exercise. And I'm not going to go into it, but as I said, this can be applied to many other scenarios beyond the one that I'm presenting here. And I'm happy to discuss them if you're interested in doing something about it. I'm going to skip the literature so far. If anyone is interested, we can talk about it later. And I'm going to skip this one as well because I'm not going to have time for sure to finish with everything. So directly to the model, players are going to be indexed by their type, theta, that is going to reflect, for example, what is their preferred type of paper that they want to produce. The economy is going to consist of a mass 1 population, defined on the domain 0, 1. The density function is going to be f, lowercase, and the population mean, the expectation of theta. The community, therefore, is defined as a subset G of the population that can, in some cases, coincide with the whole population. The game is going to be static, simultaneous, and complete information. And the key issue is that each player jointly decides, as we said, whether to enter the community, that is, whether to do research or teaching, and which action to play in case of entry, that is, which research methodology to use. The payoffs, we're going to normalize the outside option to 0 without loss of generality. And if you decide to enter, then you're going to have a utility, a payoff function, that is going to depend on your choice that we're going to call x theta, that has to be in the 0, 1 domain. And that is going to be the type of paper that you're going to produce. And in this utility function, you can see that you want to achieve the 2 goals that I mentioned before. You want to be as close as possible to your type, reflecting your preferences. You want to do papers close to your preferred types of type of paper, but also you want to get close to the average in the community. This X bar is going to be the average type of paper produced in the research community. Okay. And this reflects the idea that you want to achieve these 2 goals simultaneously. But of course, this generates a trade-off because usually the closer you are to your type, the further you're going to be from the social trend and vice versa. Okay, the key point is that this X upper bar is going to be, and this is the definition, but this different application to the literature, is going to be the average decision among the members of the community. And this is what we're going to call the social norm in the community. And this can be, in general, different from the population mean, because the community is likely to be different from the economy, as long as the community is different from the economy. The novelty is in this parameter K, that is going to be the fixed gain for entering the game. That is, if you decide to do research, you are going to get this fixed gain, which is in reality is, as we said, the flip side of the outside option and can be considered to be the net gain from joining the research community and leaving, foregoing benefits from teaching. And this could be, for example, simplifying a research grant that every researcher gets if they decide to do a research, or funding in some way. And this is a novelty in our model, and this is going to be the parameter that we are going to use for comparative statics later on. So in the second stage, the model is a beauty contest. So this is quite known. The best reply of each individual is going to be a weighted average of their own type and the social norm in the economy. And in equilibrium, the social norm is going to reflect the average type in the community, which makes sense. Yeah, so the norm is going to reflect the types of those that are members of the community. But again, it's important among the members. And in general, this average type is likely to be different from the average type in the economy. And this is a big difference because in the literature, as we said, there is compulsory entry, and therefore this is the social norm that is imposed forcefully, unlike our case. Based on this, we can obtain the equilibrium payoff for a person that decides to enter. And basically here I can normalize it by dividing everything by P over 1 minus P. And basically this expression on the right is some H that we are going to call the attractiveness of the game. And on the right hand side is basically how different my type is from that average type in the community. And hence, this tells me for each type whether the decision is going to be to join or not. Basically, this expression is quadratic. So this is a utility of a person of type theta. And it is maximized when theta coincides with the average type. So that term, this term here is 0. And I get H in that case. And they're going to be, the roots of this utility function are going to be the points at which I am indifferent between entering or not. I'm going to call these points basically U and L, but actually because the theta can only be between 0 and 1, I can restrict that to, for example, in this case, the lowest type that enters the community is going to be 0, even though this function crosses the horizontal axis to the left, but theta cannot take that value. But on the other hand, I can have interior solutions in which the highest type that enters the community is strictly below 1 in this case. So given these entry choices, the community is going to be for each possible social norm that we can think of, we can obtain the lowest and the highest type that will enter the community. And this H, as I said, is going to be the attractiveness of the game. Notice that for each value of the social norm, we can compute these functions, L and U, the lowest and highest type that will join the community, the size of the community, which is simply aggregating the density function between L and U, and the average in that community, the average action in that community, the average type. And these are functions, but they can be interpreted also as aggregator, as best responses from the perspective of the community as a whole. And because of that, we can obtain that the equilibrium in this entry stage is going to be at a fixed point where the average that you obtain in the formula before is equal to the actual social norm. Graphically, what we can have is the following. Yeah? For each possible social norm between 0 and 1, we can draw here the functions, the lowest type that will enter, which is the red line, the highest type that will enter, which is the blue line, and the average action in the economy, in the community, that is going to be the green line. And the condition for equilibrium is where this green line crosses the 45-degree line. And we can show that an equilibrium will always exist. Basically, A0 is always above 0, A1 is always below 1. So, and function A is going to be continuous. So there's going to be always an equilibrium. We can find that if finite, the number of equilibrium is going to be odd. And furthermore, we can show, I'm not going to have time, but we find that the equilibria are going to be stable if the odd numbered equilibria are going to be stable, the even number equilibria are going to be unstable, yeah, because the A function crosses the 45 degree from above, those are stable. If it crosses it from below, those are unstable. And we can have also multiple equilibria like in this scenario, but also a unique equilibrium like in this case. Once we have the equilibrium social norms, we are going to be able to classify the different communities that can arise. And first of all, we are going to do that for general attractiveness H and general social norm theta bar, not necessarily the equilibrium social norm. And basically, we can classify communities into 4, depending on the combination of these parameters. First of all, universal communities can arise, and this is going to be the scenario that is already analyzed by the literature. But we can also observe non-universal communities, especially when the attractiveness is sufficiently low, which makes sense. We can have corner communities, either high or low, in which anyone above a certain type is going to join, and that's going to be a corner high, or everyone below a certain type is going to join, and that's going to be a corner low. And also interior communities, when the lowest type is higher than 0 and the highest type is lower than 1. So we can have all these scenarios, and in particular, these three are novel. We can also find the conditions for universal communities to exist, and basically it's this one, which simply says that H has to be sufficiently high. That is, the beauty contest must be sufficiently attractive for everyone to join, which makes sense. But this is not necessarily something that the literature suggests. It simply assumes that everyone joins, or even worse, forcefully forces players to join. Okay. In terms of the equilibrium and the community classes that we can obtain, the main result that I want to show is that if H is low, so attractiveness is low, and the density function of types is strictly monotonically increasing or decreasing in an arbitrary range, then we cannot have an interior community to exist. There's not going to be an equilibrium in this scenario. What does it mean? That if the density function, like in this case, is decreasing in this range LU, there's not going to be an equilibrium. The equilibrium condition that I mentioned with the fixed point solution can be rewritten in this way, and graphically, so capital F is the cumulative function. And basically, I don't expect you to follow, but the left-hand side here is the shaded area in this diagram, and the right-hand side is this area that is highlighted with red on this second graph. Since I can rewrite this shaded area and draw it like this one, this other shaded area, I can see that the equality doesn't hold. And this is going to be true as long as the function, the cumulative function, is concave, which is equivalent to say that the density function is decreasing. And because of this, we cannot have an interior equilibrium when the density function is strictly increasing or strictly decreasing, like in this case. And this means in particular that we can have a nice scenario which is connected to the question that I mentioned before. Why? Because if that is the case, in particular in this scenario, we have that the left-hand side is lower than the right-hand side. And this means that there is an imbalance in terms of the members. Notice that in this diagram, what we are going to have is that the social norm that we are considering is the average between the lowest and the highest type, by definition, because in interior communities that is the case. But the average type that is going to arise in the community is going to be strictly lower. And this is mainly because, notice that the density function being skewed to the right means that there are more people to the left than to the right. So the type of people that join are going to be lower. Yeah, more people are going to join on the left than on the right. And hence, the typical type of paper that is going to be produced is going to be more towards the more populous, or the more populous subpopulation in the community. That is, in this case, the lower types. Graphically, what we are going to have here is something like this. So for a given particular social norm scenario, we are going to have a scenario in which the average value corresponding, which is the green line, is going to be above the 45-degree line. And hence, we are going to have a process that is going to lead us, in particular, to, the other way around. It's going to be below, the green line is going to be below the 45-degree line. And hence, we are going to have a process that is going to take us to the equilibrium. And that equilibrium is going to be to the left. And that is exactly what we observe here. So the decreasing density function is going to take us to the left in this scenario. Vice versa, and a strictly increasing function is going to take us to the right. We know that we are not going to be able to have either an equilibrium, interior equilibrium there. These two processes imply that there cannot be any solution for strictly monotonically increasing or decreasing density functions, and it has to be that if there is going to be an interior solution, it has to be in a non-monotonic region for a non-monotonic of the PDF function, which means that the density function has to be at least one maximum or minimum in that range. And this is important for our next result. But before we get there, this is the reason, this this process that I mentioned, this transition that we are observing here of equilibrium, is the reason why, or could be one of the factors that affect the question that I mentioned at the beginning. Why do not the new Silicon Valleys actually take off and become proper Silicon Valleys? And it could be the case that because the central planner wants to have a certain type of firms, for example, operating in this range, but the actual distribution of firms is not consistent with an equilibrium in that range, what you're going to have is that that is going to be a shift in the type of firms in the direction of the maximum of the PDF function that is going to take them away from the desired objective of the central planner. And we think that this is quite an interesting, at least, contribution to this scenario, and that can be expanded or applied also to other group dynamics that could be interesting to consider. And so if the research dean, for example, if the dean of the university wanted to create a specific research center, let's say, only concerned about theory, but the distribution is like this. So we have, remember that theory is theta equals 1 and empirics theta equals 0. What you're going to have is that this research institute is not going to be sustainable because there's going to be pressure to move towards more empirics. And this is what I mentioned about the unfeasibility of or non-sustainability of artificially created communities. Okay. So based on this idea that the equilibrium, the interior equilibrium at least has to be in a non-monotonic situation, non-monotonic range of the PDF, we can extend this and show that for attractiveness sufficiently low, there's going to be as many equilibria, interior equilibria, as there are interior extrema of the density function. And in particular, the number is exactly the same when attractiveness goes to 0. And in particular, I'm not going to show here, but the interior equilibria associated to local maxima are going to be stable, because although the intuition that I mentioned before is that you're going to go towards this maxima and away from the minima by the transition mechanics that I mentioned before. So that's going to be that the maxima are going to be stable, while minima are going to be unstable. And because of that, since unstable equilibria are unlikely to be observed in reality, we're going to focus on the stable scenarios.
2 minutes, Miguel, sorry.
Okay, thank you. We can have a similar results for corner high and corner low communities, but the key point, the key takeaway here is that we can have, by observing the PDF of the types, we can already have a good idea of the number and kind of equilibria in terms of stability that we can observe. So quickly for comparative statics, the idea is to check what happens when we increase the attractiveness on the social norm. And I'm going to be very quick. So the key point is that for universal communities, there is no impact because everyone is already in. For corner solutions, for corner communities, we can observe that there's going to be a tendency to moderation in the sense that you're going to move away from the borders from 0 or 1 towards a more mixed research institute, let's say, yeah, because the only way in which you can grow, so the new people that are going to join the research institute for corner low communities, for example, are going to be people with higher types than the average in the community at the time. So the average type in the new community, in the resulting community, is going to be higher. For interior communities, anything can happen, but it is going to depend on the local skewness of the PDF function around the optimum. And very quickly, the welfare analysis. Based on the results that we obtain, we can compute then the expected utility of the utility of a member of the community as in this expression. And we can observe now what happens when we increase the attractiveness, in particular when we increase K, which is H is increasing in K, so the result is the same. And we can separate the two effects. The direct effect, that is more research funding is going to increase by definition the utility of the member. But also an indirect effect, which is the second one, that can be positive or negative. And this is important. This new effect can be positive or negative. That is, it's going to be heterogeneous or potentially heterogeneous, because different people with different types can observe different types of indifferent effects. Why is that? Well, because the effect is going to go through changes in the social norm, and this effect is going to depend on whether the social norm gets closer to my type, in which case this effect is going to be positive, or away from my type, in which case I'm going to be worse off. And how much I'm going to be worse off is going to depend on the sensitivity of the social norm to the change in the attractiveness. That is, how fast or how quickly the social norm goes towards me or away from me. Importantly, in universal communities, an increase in K is always going to be a Pareto improvement. Why? Because by definition, there is no change in the social norm, so no indirect effect, and hence only the positive direct effect holds, and therefore a Pareto improvement can be obtained. And so it seems to be a policy that has to be followed every time. However, in non-universal communities, this is not the case. And as we said, some people can become worse off if the social norm is sufficiently responsive. In particular, if the indirect effect is greater than in absolute value than the direct effect, you can be worse off and still remain as part of the community, still becoming a researcher. But also, if this effect is, the difference is sufficiently high, it can be the case that now staying in the community pays less than exiting the community. And in that case, you can exit the community. That is, increasing the research funding, for example, in this example, can lead to some researchers to exit the community, even though a priori one can expect this to be a good thing, simply because the shift in the social norm is so far, or takes you to so far, moves so far away from the type of the person that they prefer to stay out. And finally, just to complete, it's important. Yes, sorry. Last thing is and finish. This increase in K. Notice that if if the dean of the university follows the current literature, could be fooled to increase research funding, believing that this is going to lead to a Pareto improvement, while what could happen is instead something like this, in which some people change their decisions and some people exit. And this could be especially problematic if you want to keep a certain social norm, because the result is not only that people exit, but also the social norm is going to switch so differently that it might backfire. That is, for example, you are an empirical department, you want to increase research on the on empirics, and following this analysis, you will increase research funding, expecting more research in empirics. But it could be the case that because of the shape of the distribution, what happens is that there is a shift. Most empiricists leave, most theoreticians enter, and you have a change in the composition that is going to be against your purpose or goals. And that's it. Thank you very much. Sorry for going over the time.
Don't worry. We have 30 seconds if somebody wants to ask anything. So I got one myself, very quick. To which extent, Miguel, so I guess for the beauty context to work, you need to allow for, there's no like entry cost. Let's say that the two of us, we want to publish a theory paper in Econometrica, and then somebody wants to join our research department, and then we are kind of forced to be pushed towards the more empirical side, right? So in our sense, I cannot say to this guy, no, come on, you are not allowed to stay here because I want to keep the quality high. You see what I mean? So I guess the entire results are mostly driven by the entry costs, which are zero. Correct me if I'm wrong.
Well, the entry costs are implicitly mentioned in the attractiveness, because the attractiveness is the cost. Yeah. So basically, you can consider it to be the net gain from the outside option. So when you enter, you may assume that you pay a cost, but still the net gain is positive.
I see.
So yeah, I mean, I see your point, but it is captured still by this parameter. So this is like the net effect. Yeah? And just a comment. The key point is that here there is no better option. It's not that empirics is better than theory or vice versa. So it's not that the quality is going to decrease by the entry of other person. It's simply that you're going to switch the vision of the department or the research institute.
Okay. Cool. Thanks.
Thank you.
All right. I think if you can, yeah. Now it's my time. I want to put the my own timer here. Hope you can see this. Yep. Okay. So thank you for staying to the very last part of the presentation, I guess. This is joint work with David Melkanji. David is at the New York Fed, so the usual disclaimers applies. And the title of the paper is Subsidizing Startups Under Imperfect Information. So, okay, sorry. So the motivation for the paper starts with the fact that, well, firms in general, but particularly small firms and startups are proven to be one of the key drivers of aggregate job creation and productivity growth. Among this group of small firms or startups, there's a lot of heterogeneity, and particularly there's a lot of ex-ante heterogeneity, meaning that before entering the industry, you are really not aware of your productivity, or you're not really aware how big your firm is going to be once you become an incumbent. Okay, and this is relevant because there are policies, there are like accelerators, our business that are trying to put money on the table to support these firms, particularly to support startups, and in the form of grants. So it is relevant to understand to which extent there is an interplay between the imperfect information of the firm and the ability of the policymaker to really boost the entering of this type of firm. So this is going to be the main motivation of this paper. And I wanted you to think about the problem of a startup. Think about the startup productivity. You really don't know the amount of competition that you're going to face once you're entering the industry. You really don't know if your product, your idea is going to be cool enough for you to sell them to people. You don't know if you're going to face a high or a low demand, things like this. And this is not only don't know for us, for the researchers, but it also is unaware for the policymakers that want to design a policy to support the industries, and actually don't know for the policy for the startup itself. And here we have a very nice quote that we like, meaning that, well, a startup is in essence as like an experiment with potential, which means that, well, startups are prone to failure by definition. In the data, around 25% of the startups die after 1 year after they enter into the industry, because in a sense they're just testing assumptions, and it's very likely that these assumptions are wrong. So you got the idea that you got your idea, you got your app, probably you will become Google, you think you will become Google in the next few years, but then the reality is that, well, with around half of probability you will die after 2 or 3 years. Okay, and then for the policymaker point of view, this is going to be difficult to assess the effectiveness of a policy that wants to support startups, mostly because the policymaker is not going to observe the share of firms that chooses not to enter into the market. And this is going to motivate us to build a model with entry and hiring decisions in order to study the effects of grants to startups. And this is precisely what we're going to do in this paper. We're going to build a rational inattention model of startups. Rational inattention is a way for us to model imperfect information. I'm going to be more precise about this in a minute. But then the key thing is that through imperfect information, we want to allow that the imperfect information to interact with the two margins of the startup. First, is going to affect the decision to enter into the market, which we're going to label the extensive margin. And also it's going to affect the decision about the size of the hiring. So once you decide to enter, you need to choose how many employees you want to hire. And this is going to affect your initial size. Through the information friction, we're going to show that the model is going to, generate two main results. The imperfect information is going to generate what we label inefficient entry. I want to tell you in a few minutes what I mean by inefficient entry. And also the imperfect information is going to generate both under and over hiring relative to the first best. So the first best is the scenario what startups had actually full information. They are aware of their productivity. They know their demand they're going to face. They know the amount of competition they're going to face. And because of the imperfect information, it's going to distort the decision of hiring, which is going to transmit in a large dispersion of marginal productivity of labor, which in macro we call this the misallocation. Okay. Then after computing this novel information channel, I'm going to show you the effect of a policy that's going to provide some cash to the firm, to the startup. Think again about an accelerator that's going to provide money, put money on the table to the startup. I'm going to assess the consequences. And I'm going to show you that, well, the policy will have 3 unintended consequences. One is that there's going to increase the inefficient entry of the firm. Second is going to reduce the hiring of the firm, even for productive startups. And then there's going to also to increase the misallocation. Then we're going to, so for the sake of this presentation, I'm just going to show you the main mechanism that supports these results. But then I want to show you that the imperfect information is going to have an interplay with some positive channels of the policy, particularly when we allow for firms to have some forward-looking behavior in the sense of building a dynamic model. I'm also going to stress the implications when we allow for financial constraints hitting the startups. Okay. Well, for the sake of time, I'm going to skip the literature. It's not really the main issue today, I guess. Let me just, sorry.
I think your slides are frozen up in your title slide.
In the title?
I'm only seeing your title now.
Really?
For all, for all your talk up to now.
Okay, sorry. Thanks for that.
Yeah, we're seeing the file. Yeah, that one.
This paper you're saying, right?
Yeah.
Okay, and now you see that moving, right?
Yeah.
Okay, cool. Okay, so but yeah, thanks. So what was the okay? So the last thing I said, correct me if I'm wrong, is that, well, although we will have some negative effects here in terms of the information frictions, then I'm going to allow for more realistic scenarios for the startup. In particular, I'm going to allow for some forward-looking behavior from the part of startups, and then also we're going to allow for financial constraints to affect the startup. Okay, this is the part where I said that I'm going to skip this slide, and hopefully you're seeing this and you see me skipping this slide. All right, so let me show you the model, the very basic or stylized model I want to solve. So think about one period framework and think about you have to choose an action, which are going to label as N. N stands for hiring, so you're going to choose the size of your firm. And you will face information, and you have to learn about your idiosyncratic productivity, which I'm going to label as Z. So think about the productivity as the business conditions or the demand you're going to face, whatever, okay? So, and C is going to be an observer for you. The profit of the firm or the startup is given by this equation number 1. Obviously, if you choose not to hire anybody, you'll stay out of the industry, so you make 0 profits. And then, if you choose to hire, you will face like this typical decreasing returns of scale profit with just one production factor, which is in this case labor. And you have 2 costs: the variable cost, and then you have a fixed cost, the fee. Okay, forget about tau for a minute. Tau is going to be the subsidy. So for now, to fix ideas, assume that tau is equal to 0. Okay, so you face 2, a fixed entry cost and a variable cost. So 2 scenarios here. The first scenario is that, well, think about full information. In full information, you know with full certainty your productivity. Okay, so then given the fixed cost, you will know if your productivity is high enough, so you should enter. Okay, so the decision to enter is going to be defined by the cutoff rule of productivity, okay? And actually, if you choose to enter in this case, the cutoff implicitly is going to define a minimum production scale. So conditioning on entering, you know that you will hire at least, let's say, 2 employees, okay? The second scenario is a scenario where you we have imperfect information about your Z, about your productivity. And this is where the rational inattention comes in. So under rational inattention, the firms are going to choose actions now given their beliefs about Z, okay? And what is the learning problem that the firms or the startups are going to face? First, they're going to design what we label an information strategy. This means that the startups are going to actively collect information. They're going to choose how much information to acquire and what to pay attention to, in the sense that they're going to design their own signals in order to learn about their productivity. And then conditioning on the beliefs about Z, they're going to design an action strategy. So then, given the updated beliefs, they're going to choose an action, okay? Whether to stay out or in the industry, and then also whether I should hire, let's say, 2 or 3 employees, okay? These two strategies, the information and the action strategy, depends on your prior beliefs about Z. And this is like a theoretical result. Instead of solving these 2 stages separately, you can merge these 2 decisions into one, and you can collapse the decisions in terms of just showing that, well, for solving this problem, you need to characterize the joint probability distribution between actions and state, which is the problem that you see here. So actually, the problem under imperfect information boils to choosing the joint probability distribution of actions and states in order to maximize this. And this is nothing more than, the first part here is just the expected profit of the startup less their information cost. For me, learning is hard, learning is costly. I cannot acquire all the information that there is around there, but the cost of information is driven by this parameter theta. And then under rational inattention, this was Sim's original idea, we can collect information through Shannon's mutual information. So this kappa here basically is the amount of information that I want to acquire. The more I learn, the more costly it is, but obviously, if I learn more, I will have a more precise signal about what is my true productivity, and I will be able to maximize the expected profit. This is the trade-off that each firms face in each moment in time. These are more the theoretical results. I'm not going to spend much time talking about this, but the nice thing is that we can characterize the solution for this problem in this form, which is equation 3. This just says that, well, the solution of the rational inattention problem boils to a multinomial logit, and then we can characterize, and then we're going to put in the computer this equation 4 in order to generate the posterior and the marginal probabilities by solving equation 4. Okay. This is more on the theoretical side. Let me just jump to the results. So the first finding is that, remember that imperfect information generates this, what we label inefficient entry. Okay, here in black, you got the distribution of the productivity. Okay, then in blue, I know you can see it. In blue, it is the full information scenario where I actually observe my productivity. You can see there's a very clean cutoff in terms of the productivity, and this is driven because of the fixed cost. Remember, so if my productivity is low enough, I should stay out of the market. Me as a startup, I know that I'm going to face a very high or fierce competition. My productivity is not enough. I should stay out. Okay, and this will happen if I am able to observe the productivity. And you can notice that this very clean cutoff basically disappears when we allow for the imperfect information. In particular, look at this. So red is the rational inattention scenario. Look at this yellow area here. The yellow area is the group of firms that, although their productivity is not high enough, so they should stay out of the market, still, because of their noisy signals that are receiving out of the productivity, decides to enter. This is the inefficient entry. And through this, you can reconcile the fact that, well, after 1 year, 20 or 25% of the startups will die because their productivity wasn't really high enough. And this is what we label the inefficient entry. And on the other side, here in the pink area, you have the inefficient non-entry, which is the group of firms that, although their productivity was high enough, so they should enter the market, they decide to stay out. So they think that the productivity is not high enough, and they endogenously chooses to stay out. So this is only on the extensive margin. Then if we focus now on the intensive margin, so this is the decision about sizes. I don't know if you can see it, but here in blue, you get the decision under full information, which is just this continuous function, which will decide your size if you are able to see your productivity. And in red, you have the ratio inattention. Here on the left, sorry, on the right, you got the zoom version of this first part of the distribution here, okay? What I want you to focus is two things. One is that, and this is a very known result in this theory, the probability of sizes degenerates in a subset of points. So you can see that the startup is going to optimally focus zero attention on this subset of actions here. Here we are using like 2,000 points. It's not so this result is not driven by the discretization of the domain. Okay, this is a theoretical result in this literature, which means that since information is costly, since for me providing attention to all the possibilities is very costly for me, many options will receive no consideration. And this is what Kaplan and Dean calls the consideration set in this literature. That's one thing. And the other thing is that, remember that because of the cutoff, you got a minimum production scale. We have both under ratio inattention and under full information, we have a set of dominated actions, where you can see here, which means that if you choose to enter, you will have no mass here. So nobody's going to enter with, let's say, 1.5, and this is continuous, obviously, 1.5 units of workers or hours if you want. Okay. The third thing is about misallocation. Remember that under full information, I observe Z, so I will make no mistakes. The marginal productivity of labor is going to be exactly equal to the wage. This is the first order condition of a very simple production function with just labor. But then under ratio inattention, you get dispersion, you get misallocation. And the model is able to endogenously generate this misallocation, which is consistent with the data as well. Misallocation has been proven in the data to exist even within very narrow defined industries. And the model can generate this as well. Okay, so now let's think about the accelerator. So now let's introduce a grant. Let's do a transfer to the startup. Now the tau is going to be greater than 0. What this means is that since I'm providing cash to the firm, the cost of entry, remember this fee cost, is going to decrease. So in a way, I'm going to reduce the cutoff, and more firms should be willing to enter into the industry. Okay. In terms of the full information scenario, nothing should happen for the firms that were already entering. Okay. So if I was entering before the subsidy, I should obviously enter after the subsidy. In ratio inattention, we will have some differences in the sense that, well, we're going to add through the subsidy some new actions that were before well dominated, and we are going to add a subset of actions that are no longer dominated. That's one thing. And we are not only adding new actions, we're also adding actions that had greater probability of occurrence. I'm going to show you the figure in just 1 minute. And this will bring non-trivial implications for the learning problem because, well, under ratio inattention, you have two results here. The model is non-regular in the sense that adding new alternatives is not free. You can start putting more attention to new alternatives relative to already existing alternatives. And then is a property about monotonicity in these problems, that if I throw you more action that have a higher unconditional probability of occurrence, you should put more attention to this as well. Okay, so this is the effects of the transfer. Under the two scenarios, under full information and under ratio inattention, you can see that under imperfect information, we got an amplification in the share of entrants. The increase was 5% under full information, and with imperfect information, we got 13% more firms entering into the industry. And this is actually driven by an amplification of the inefficient entry. So here you can see in blue, in blue, you can see that how the cutoff is moved to the left because of the transfer. So you got a new position for the cutoff, but then you got an amplification also in terms of the of the inefficient entry. In the paper, we'll provide some intuition for why this is happening, but just to give you an idea, because this simplification with imperfect information is mostly driven by now firms that shouldn't enter the market that end up entering. What before was this yellow area, I don't know if you remember. Then in terms of the intensive margin, the average employment, and here we're conditioning on firms that were already entering before the transfer. Under full information, the effect is 0 by construction. So you were far away from the cutoff, you were already entering without the transfer, you should keep your size fixed, right? But we show that under rational inattention, the firms, even the firms that are already entering, chooses to enter with a smaller size, actually 1.5% smaller. And this is because of this. So here, throughout the distribution of firms, we collect the distribution of firms in quantiles, and each of these dots here is the medium of each quantile. 0 is the effect under full information, so 0 effect. And you can see how across the board of firms, and particularly the ones that are closer to the cutoff, these are the smaller, the less productive ones. When the transfer hits the economy, this group of firms particularly are going to choose to enter into the market, but with a lower initial scale. Okay, these are part of the unintended consequences of the transfer. Okay, let me just skip this for the sake of time. Okay, so now, so having documented this kind of negative effect of the transfer, let's try to put them all in a more realistic scenario. So you can claim, okay, so a static model for startups is not really realistic. Startups are hoping to stay for more than one period. So let's put some dynamic here, and let's assume that the startups are forward-looking. So in the sense, I'm going to allow now for a dynamic or particularly a 2-period model. The model is going to be exactly the same, with the only difference that in the second period, we're going to allow for an adjustment cost, which is given by this gamma here. Why the adjustment cost is because without the adjustment cost, then the dynamic problem would just be a collection of static problems. So there will be no dynamic, okay? And also in the dynamic problem, without, after the first period, since this profit is static, after the first period, I can actually back out completely through my profits. I can back out completely the actual productivity. So there's no uncertainty in the second period about no uncertainty about SET in the second period. Okay. So why the decisions are forward-looking is because then if tomorrow I'm going to face an adjustment cost, then the decision of tomorrow's size is going to be affected by today's decision about the size. Okay, everything else is the same, but then the fact that we're allowing for a forward-looking behavior in startups is going to actually work as an attention-grabbing effect. So because of the forward-looking behavior, I now, as a firm, before entering to the market, I want to collect more information than before in the static scenario, and this will bring that, well, there's a reduction in this misallocation. Sorry, it's a reduction in the inefficient entry. Before was 13%, and now with the forward-looking behavior still is positive, but it's less than in the static scenario. The distortion in the intensive margin, remember that this was 1.5, now is reduced. If you sum these two numbers, you get something like 0.9. I should wrap up now, and also the misallocation. So there's less misallocation in the forward-looking scenario because of this, and this is again driven because I'm choosing to learn more than before. And then on top of the dynamic problem, we're going to allow for startups to face financial friction. This is a very common, I guess. So like a small firm, a new firm is probably very prone to face limitations in the access to the credit market. We're going to assume that where there's a wage bill mismatch between the time that when you need to pay for the wage bill and your productivity, you need to get an inter-period loan in order to hire. And then we're going to then assume a financial friction in this sense through an earning-based constraint, as you can see here. Okay, so in a nutshell, the main idea is that now, even under full information in this scenario, they will still have misallocation in terms of the firm. And here are the results. But the main takeaway for me is that once you allow for the dynamic setting and once you allow for the financial frictions together, now even under imperfect information, you had some slightly positive effects of the transfer, which is consistent with the data. And typically in the data, when you study the effects of subsidy to startups, the effects are almost zero on average for several countries, and this is consistent with the theory. But this is because, and I'm going to finish now, and this is because the negative effects of the imperfect information are more than overturned by the fact that firms are going to be forward-looking and the fact that firms are going to face financial frictions, and then obviously the subsidy is going to make this financial friction less stringent in this case. We have another scenario where we allow for the wage subsidy, but I'm going to skip this for the sake of time. I'm happy to hear your questions or thoughts.
So Javier, may I ask you one very short question?
Sure.
I guess when you talk about subsidizing startups, there are many ways to provide those subsidies.
Sure.
And like you in your model, you could subsidize the hiring, for instance, the hiring of people, right? You could provide a per unit subsidy per unit sold, right? Or you could provide a lump sum, or even you could provide this transfer just to the most productive firm, like kind of use a cutoff rule. And so my question is, why did you pick this? If I understood correctly, why did you pick this form of lump sum transfer to all firms that enter? Is that correct? So any firm that enters, I give them a lump sum transfer. Is that correct?
Yes, that's correct. So all firms in the distribution of firms are allowed to get the transfer. But you're right. So I don't need to. So one thing. So we allow for the transfer because we didn't want to distort the first order condition. Okay, so of the firm. Having said that, we allow for different ways for different policies, particularly as you were saying at the beginning. So there are policies that I get money for my startup, but that money has to be used exclusively to pay wages to my employees, or some combination of both. So in Startup Chile, you receive 10,000, let's say, and then half of that should be used for wages, and then the other half should be used for R&D, let's say. In that case, and through the lens of the model, if you allow, for instance, for a wage subsidy, you can still have the unintended consequences, but most of the effects are overturned. This is the part that I didn't get time to show. But so the takeaway is that it's because of this non-linear interplay between how you choose to learn and how the policy is affecting your hiring decision. You can have either some unintended consequences, or you have some unintended consequence, let's say, of the policy. But you're right. So it actually depends on how you design your how the accelerator designs the way that startups are going to receive these grants.
Right. And the other question is, as you pointed out in the beginning of your presentation, when you talk about startups, there are a lot of uncertainty, right? As you pointed out, you could become Google or you could die, right? Yep. After like 1 month. So my question is, when you talk about subsidizing startups, isn't implicit the fact that there is imperfect information, some sort of imperfect information?
Yeah, absolutely.
Yeah. Yep. So maybe this is just an advice or just one comment, and shouldn't the title just be subsidizing startups, right, or funding startups? Because it is implicit the fact that you're going to be facing incomplete information, right? But
yeah, I see your point. So, but our only point is that the imperfect information is all over the place. It's from the startup point of view, from the policymaker that doesn't really know which of this group of startups is going to become Google, as you were saying, or is going to die after 1 year. and it's going to be unobserved for us, the researchers. So it's like a three-way part of the imperfect. That's why we're collapsing everything under the imperfect information scenario. But I agree with you. So obviously the startups are prone to imperfect information. That's a fact. Yeah.
Okay. Okay. Yeah. Thank you. Thanks.
Cool. Thanks. Thanks.
May I enter as well? Yeah, very interesting. I was wondering, connected to the question of Tono, regarding the fact that the company or the government or whoever could actually decide, for example, to provide the grants to the companies based on their expected return. It could also be used as a signal. So the fact that you are offered that grant, you know, could be some kind of a signal for the market, in the sense that the other people that did not collect any information could get some information from that as well. In a way, it can be. I don't know whether I'm on the right track or not. It's not my topic, but the idea could be whether the grant could be, in a sense, not necessarily be in terms of money, but in terms of, I don't know, market research that the government could pay for market research in order to learn what is going to be the market demand or whatever for a given app.
Yeah, absolutely. Yeah. So again, I cannot stress enough how hard it is to solve this problem. Numerically takes like several days for this to compute, and we run it in the New York Fed computer, which is a massive cluster. But point taken. So there's two things. So one is about reputation in the first part of your question. So perhaps by getting these grants, I can signal the market that I'm one of the cool startups, and this plays more like kind of repetition of a game. And even to extend the model, which is static at the beginning, to the dynamic setting was already a pain. So probably we need to think about more how to extend this in a dynamic to allow for this. But then so perhaps the transfer, the subsidy is more to improve my own productivity. So to use it on R&D, and perhaps through this, I can have a new Z. I can improve my Z, my productivity, by doing this. And this is a possibility. We thought about this, but for time restrictions, we haven't been able to do it. But yeah, but thanks. That's a very good point.
Welcome. No, it could be the case that I don't know, thinking about the venture capitalists, for example, could have more knowledge and more know-how about the industry, and therefore they have an advantage, an informational advantage, that they can pay, that the cost for them of providing information is lower than giving the money to the startup.
Yeah,
something like that.
Yeah, you're right. Yeah, yeah, cool. All right. I think we're done here. In 8 minutes, we have the last talk. So it was very nice, very, very, very interesting, the 3 papers. Thanks.